off, my name is Surini, and I'm a grad student that's going to be sitting in this class. So what I'm going to do is hold 2 office hours after class here, Mondays and Fridays. We're going to be here for half an hour, but then there's another class, so if there's anyone remaining, we'll go upstairs to Charlie's Cafe. So if there are questions that you have in class that we didn't have time to answer, then just like you can go to your TAs, you're also free to come to me. Oh, I need applause for that. All right.
So we have another TA, basically. We have another TA. And it's Surini? Surini. All right, so we basically have a 4th TA now. I will post these hours on Blackboard along with my hours and the rest. I'll show you Blackboard in a second. Other announcements that are important, okay? So today we're going to have 15 minutes for the quiz from the time that we start, okay? So just relax. Important stuff here. Reservation attendance. I just want to review the policy about this. The way this works is over the course of the semester, you get a cushion of 1 miss. All right, so don't use that up. You may get sick. Something might happen. So don't. You get your 1 cushion, but then after that, your overall grade in the course starts to come down when you miss recitation. And the more that you miss, the more it jumps down. So like after missing twice, your grade goes down 1% in the class. If you miss 3 times, your grade goes down something like 3%. All right, but the exact thing is on the syllabus. I just want to remind you, recitation is required, and there's no specific grade for it, but if you miss, your grade just goes down and accelerates down as you miss lots, okay? Exam 1 is this Wednesday evening, okay? Some of you have made other arrangements with me, and we've been in touch on email. But everybody else that I haven't heard from, you're going to be at PSA 21 from 6:15 to 9. So you can come later than 6:15 if you'd like, but I recommend this first exam is a little bit shorter than the others. So just to be safe, maybe come at the latest 7, okay? And that way, if you get done early, you're free to leave, but just make sure you're giving yourself enough time. You can start coming at 6:15, and that's in the basement of PSA 21. Those of you who have gone to the math testing center before, that's the same room. It's the same room. Okay, what does it cover? It covers everything we've done, Module 1, and then we're going to do Module 2, Section 1 on Monday with homework for Wednesday. That will also be covered on the exam. Okay? And I'll post some review items on Blackboard. It won't be extensive, but it'll be a compilation of quizzes similar to the quizzes you're taking in class. Maybe it's just like 2, right? So there'll just be some more, but it won't be like this full comprehensive review. But do look for, I'll post some review items. Also to help you study, I'm gonna post, some of you have noticed that I have posted a homework solutions. So there's full solutions to the homework. I think that I've posted for Mod 1, Section 1, but then this weekend we'll get caught up with those, and then also quiz solutions. So this will be helpful for your studying. What I recommend is that don't start your studying with the solutions. Try the problems again by yourself, like you were taking the exam. Okay? You won't remember. Okay? You won't remember. There's so many things going on in your life. You won't remember the problems and the numbers. Work it again like it's the exam. And then once you've done the very best you can, then look at the solutions and try to figure out what you're missing. But if you're start studying from the solutions, this isn't the best experience. Okay? Because you just read it, you're like, oh, I get it. But could you have done it? And that's the testing experience. Okay? So, is that all the announcements? Let me show you Blackboard, all this stuff in a second. Here we go. While I'm pulling Blackboard up, any of these questions related to these kinds of things, announcements and such? Okay, so of course, readings and homework you know about. So I've started this new area, GC Keyboard Shortcuts. That's a document that has some of the most commonly used things or commands that we'll need in GC and how to do it on a Mac and on a PC. And then you can also find many things in the help menu. on GC, if you go to the help menu and go to keyboard shortcuts, that's also a great resource for that kind of thing. So here's the homework solutions. As you see, I've posted this for all of Mod 1 Section 1, which is actually 2 homeworks. But then this, over the weekend, we'll get this up to date of everything that you turned in, okay? And then, maybe I'll change the name of this, and it'll be homework and quiz solutions. And then we'll have the quiz solutions here too. And I'll put up a blank copy of the quiz along with the solution copy. Okay, of course, class videos. Remember that I'm videoing every class for you to go back and review. Any kind of announcement type questions like this? Exam is Wednesday night. I got 138, so let's do to 153. Oh, okay, shh, don't do that, Shh, we're still going. Okay, so the first thing I want to tell you, I should have mentioned last time. So remember we talked about parameters, like anything that graphic calculator doesn't use, like capital B or capital T, you can define as a parameter. You can also define a character string as a parameter. You should have seen that in the homework. So to do that, you do backslash, which is right above return, and then type in your string, M-A-T, so math, okay, string meaning more than one letter. So then hit it again, hit the backslash again, and they disappear. And now that whole, what we call string, or those 4 letters all together makes one parameter. It's not M times A times T times H, right? So by doing those backslashes around it, you create a variable or a parameter out of the whole word. Does that make sense? Okay, so that's helpful. For instance, we're going to define a function called left, named left. So L-E-F-T, and now I'm going to do control 9, say A. And then I'm going to say equals, and then I'm going to have my rule using A. So now that whole thing, L-E-F-T, is the name of the function, rather than meaning multiplication. Does that make sense? All right. So let's talk about points. So how can we plot a point? So I'm going to... So here's our area of the circle function, right? On the x-axis is what is represented there on the x-axis? Radius of the circle, and then corresponding on the y-axis, area of the circle, okay? So we've got our, let's turn off the y equals pi line. Okay, so to plot a point, you hit control, to start a new command line, hit control 2, and you get like vertical brackets like that. Brackets with vertical brackets. And so we can put in x comma y, so I can put in, say, 4, and then 5. And we'll make it black. Okay? And that's not on the screen, so I want, what do I want? 0.85. There we go. See it? So it just plotted that point for me. So this is how you plot points. Control 2. So what if I want to plot the point at a radius of 0.8 on this function? So corresponding to a radius of 0.8 and the corresponding area. So how could I change this now? What could I put down here? Yeah, so let's use our function notation. So what am I going to type in there so that I get the actual point on the curve for a radius of 0.8?
P whatever.
He wants P, well, of whatever? Whatever I want? No, 0.8. This will give us a radius 0.8, and then what's this? What does that mean? The second, the y value. Corresponding area of the circle for radius of 0.8. So there it is on the circle. Or sorry, on the graph. So look, so you didn't have to go get out your handheld calculator and go 0.8 squared times pi, and then type in a decimal approximation. All you do is P of 0.8, and that's your area of the circle with radius 0.8. Yeah. Control 2. Control 2 gives you the blank point. Okay, so that's how you plot points. The next thing we want to do to start using animations is what's called sliders. Sliders are really powerful so that you can control the value of the parameters. So graphing calculator has a built-in slider, and it's lowercase n. So as soon as you type lowercase n, so you see down here at the bottom this thing called a slider pops up. Okay? And what that allows you to do is you can either hit play or you can grab the button and drag the button. So now if you look up here, so by putting n, it's just giving me the current value, and that can change as I drag it on the slider, it changes it. Or you can just hit play, and it will just automatically sweep through, continuously sweep through values of n. So what I want to do now, I want everyone to think about this. I want to use n as the radius, and then I want to be able to, if I slide the slider for n, I want it to track the corresponding point on the curve. Everyone think about this. How am I going to have a movable point on our function? Movable point on our function giving n and the current value of, in this case, area at n. So how would you, was there a question?
Yeah. How do you get n without the bullet?
Just type n. So how are we going to, I want this movable point, I can move it along the curve, giving me any ordered pair on the function that I want just by changing n. So what will the x coordinate be? N. And what will the y coordinate be? P of n. So now whatever n is at the moment, it's going to plot the point n and n plugged into our p function, or the area. So notice that n starts out from 0 to 10. So that's not very convenient on what I have on the graph. I would kind of like n to be maybe 0 to 2. You see that? So here's how you change the range for n. Click on n. So for your slider, you can specify then the lowest value, the highest value, and then how many steps in between. So suppose from 0 to 2, and I want it by tenths. I want to be able to change it by tenths of whatever, a foot for my radius. So how many steps would that be? If it's by tenths, how many steps from 0 to 2? 20, right? 20. It's by tenths. So now hit OK. So now my slider's been adjusted so that it stays on exactly on 0, 0.1. And then as I change it, the point shows up according to the current value of n. So np of n will give me my point, and then I can change n. It changes the location of the point.
What if you set n equal to p of x?
It doesn't make any sense. Because n is a parameter, p of x is a function, an output of a function. So you're trying to, those are two separate things, you're trying to make them equal, so that doesn't really make sense. Okay, other questions about that? Okay, so the rest of, this is all also, what I'm going over here is also part of that document, or the homework for Monday. It's kind of a tutorial. It kind of guides you through and it's teaching you new things as you go, but there's still a mathematical problem-solving element to it. In the end, if you make it through and do everything correctly, this is the end result. And I'll post a video of this. So in the end, it deals with a function. This function, a of t, there is the attendance given, the expected attendance at a football game given the temperature outside. Okay? And so you're going to follow all the stuff, and in the end, if you do everything correctly, this is what it creates. This animation. I just set n changing. And it's going to create this, the movable point, along with, what's it showing? It's showing a change of 10 degrees and the corresponding change in attendance. That's what that shows.
Why does the triangles like flop up and down?
What's that?
Why does it like change direction? Why does it just go all the way on the bottom?
Okay, so given a point in a function, it makes sense to talk about the change in input first, and then look at the resulting change in output.
Why meant the triangle? Why is it?
No, because from that, I'm answering your question. From that point, you want the change in input first. You always want it from that point. You want to show a change in input first, and then show the resulting change in output. So that's why it starts at that point. It goes to the right, and then does the same thing over here as well. Starts at that point, goes to the right first. Change in input first, resulting change in output. I think I'm answering your question.
Oh, I was just wondering why the triangle itself switches sides from the bottom to the top.
Because when it descends,
No.
you're going down.
So input is first. From the point, you want to show a change in input first, always. If it does this, you want it to do this. Well, that's output first, and then input. This is showing input first, resulting change in output. Okay, so this is the final product of your homework. So as you're working the homework, you want to have GC out, and as it's taking you step by step, make sure everything is appearing the way it should. Okay, appearing correctly. If you get stuck, you can try emailing one of us, and we'll try to help you. Okay, cards.
I was just going to ask if we'll ever get to the part where we can actually put arc
Oh, it's easy. You just have an image file. You just drag it onto. I'll do it right now.